All right, part 3. Here we go. Almost done. You can see the finish line. Let's get at it. Huh. Wow, that's not very good ending up. Let's see. What does that even say anyway? Use an identity. Well, what does that mean? Well, we'll see that if we think of this one like the last one, right, where I can think of A as cos x, but then what would I have? I had negative 10 not cos x, rather, A as cos x, not cos x squared, A squared, right? This is kind of like that. But then this isn't the same thing. This isn't A, this would be B, right? And equals 0. This is no good. I can't factor this, right? I need to have all the same variables. So what the idea is I need to have this all in sines or coses, right? Need all sine x or cos x, right? That's what I need. So I'm going to tilt my head sideways, read the strategy, which is use an identity. What identity sort of connects sines and coses? Well, there are a few, but that should ring a bell, right? If I have sine squared x plus cos squared x, and that's what I have, equals 1, I could move that to the other side, and I get cos squared x equals 1 minus sine squared x. And I know a lot of you, because of all the identity solving that we've got, know that one straight off. That whenever I see a cos squared x, I can put in 1 minus sine squared x, and we're good to go. And that's what we're going to do, actually. We're going to solve this equation, which I know it looks worse, but only for a second. Only for a second that's going to look worse. Multiply through, collect like terms. All right, multiply through by 10. Not in here, so I'm going to copy down the rest of this. Equals 0. Like terms there and there, so I get 10 sine squared x minus 3 sine x minus 1 equals 0. And then, now, I can sort of see the pattern. Now I've got, if A is sine squared x, this is 10a squared is sine x, not sine squared x. Then this is 10a squared minus 3a minus 1. This is now a grade 10 factor question. And does it factor? Yeah, it does. This is, I could think of 5, and I'm going to use trial and error again. 5 and 2, right? There's not many things that multiply to get 1. I just got to get the signs right. So 5 times minus 1 gives me minus 5 plus 2a, and there it is. I don't even need this extra step. I don't even know why I put that in there. So now I've got my two factors. Where a was, I'm going to put sine x. Plus 1, and 2 sine x minus 1 equals 0. And then I get these two equations. I get 5 sine x plus 1 equals 0, and 2 sine x minus 1 equals 0. And again, we can just proceed and solve. How would I do that? Well, I got to put the 1 to the other side, divide by 5. This isn't a perfect angle, so this is one of the diagram calculator think ones. This one, when I solve for it, 1 goes to the other side, divide by 2. This is a perfect angle. This is one of the chart ones, right? So this one's easier, I think, because I don't need to use my calculator. How does this go? Well, this is routine stuff, so I'm going to try and zoom through it. Diagram, rotation angle, a y-coordinate of -1/5, or I could think of the cast rule, or all soup turns cold rule. Where's the sign negative in these two quadrants? Right, there are my two solutions. Right here is x1. Right here is x2. Now that I got my diagram, I can use my calculator. It gives me it's going to give me a negative angle again here, negative 0.20. And so that tells me that the raw is 0.2, about, rounded. And so it gives me my two solutions from this one. X1 is pi plus 0.2, right? Because there's my related acute angle, which is about, rounded, 3.74. My x2 is almost 2 pi. Subtract the related acute angle, which is 0.2. And all of these are approximate solutions, this is 6.08. And then that's it for this side. This side gives me a bunch more solutions. And again, I recognize this is a perfect angle. The related acute angle is pi over 6 from my chart, or from however I think of that. And I can think of, where is the y coordinate, a half, or I could think of just knowing that the related acute angle is in quadrant 1 and quadrant 2, right? There's my x1 from this one, my x2 from this one, x2. And I know I'm going fast, but at this point it's old stuff. This is old review stuff, right? The only new stuff was this stuff. So I'm going fast through this. Maybe you're not even listening to me. Maybe you fast forward it because this is so routine now, right? First angle was pi over 6, just the related acute angle. Second angle is pi minus pi over 6, common denominator if you need to, 5 pi over 6, and then collect up the solutions. And these are principal solutions. Maybe I should have said that. The principal solutions, some are exact and some are approximate, but there they are. There's 4 solutions. All right, on to the last example. What made that one hard, by the way, was, remember, we didn't have all the same variable. And we got the same thing next time. Okay, hopefully that'll quit soon. Yeah, there it goes. So it's not the same thing, right? It's not the same thing. We've got like A's and B's. There isn't a common factor because of this 2. But the strategy is like a couple of steps. Identity quad formula, that makes me nervous. What does that possibly mean? Quad formula with trig equations? Wow, not looking forward to that. But what's the identity that we're talking about? Well, we need to have this all in sines or coses or tans or secants or whatever, right? Well, I remember, maybe you remember too, there's something about the secant squareds, right? We have this form of the Pythagorean identity, right? Where I see secant squared, I can put in 1 plus tan squared. So 1 plus tan squared x can go in there. And then I have 5 tan x equals negative 2. Let's rearrange this so it looks like a trinomial again, right? This has got to go on the other side. Let's shuffle these terms into the right order. 5 tan x plus 2 equals 0. Okay, dandy. This looks better. Even though it's tans, I can think of my a as tan x, and I'm going to factor over here. I got a squared plus 5a plus 2. And did I make any arithmetic errors there? Yes, I did. Why didn't you correct me, right? When I move the 2 over to this side, it goes with the 1 to make 3. Did you catch that error? Well, then why didn't you say anything? All right, good. And then we factor this. Numbers that multiply, the simple trinomial this time, right? Don't need any box method or trial. This is just numbers that multiply to get 3 and add to get 5, and this doesn't work. Oh no. Oh no. Doesn't factor. So does that mean I get to quit? No, it means that I can use the quadratic formula. That's what that's all about. Quadratic formula, right? So then I'm going to have, if I had this equal to 0, right, and that's what I do. I have this equal to 0. That's what I'm trying to solve. This is equal to 0. I can use the quadratic formula. A equals, where B is 5, A is 1, B is 5, C is 3, and I have negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 3. Everyone remembers the quadratic formula, don't we? And then we get a couple of answers. We get down here, running into the homework now, dot, dot, dot. I'm going to put in dot, dot, dot. I get A is about negative 0.697, or A equals negative 4.303. You can check my arithmetic. I hope that's okay. So what does this mean? This is all my side work. Well, I don't have A equals that. I have tan equals that. So using the quadratic formula here, using the quad formula, I have tan x equals negative 0.697, or tan x equals negative 4.303, and this gives me two grade 11 equations again, right? This is the same old story, right? This is two copies of the diagram calculator think questions, right? Diagram, where is the tangent negative? Well, the tangent is negative. Tangent is negative in this quadrant and this quadrant. It's positive in these two. So these solutions have to be here. There's my x1 there. My x2 is all the way around here, right? And so that's my diagram. And I can think of now my calculator. What's my calculator going to give me when I put in x equals tan of minus 1 of this? It's going to give me the related acute angle. I think it'll give me the negative of the related acute angle. And then I end up with, in this case, x is negative 0.61. So then I get, therefore, the related acute angle is positive 6.1, and then that will give me my two solutions. X1 is pi subtract this. I'm going to skip some steps just because I think you get it now. We've done enough of these linear ones that you get the picture. This second solution is either the first solution plus pi or 2 pi subtract our related acute angle. And yep, I get it, Restall. Please stop talking. I want to go do some homework. Yeah, I know. Just hang on. And again, same thing. Two more solutions where tan is negative. One in this quadrant and one in this quadrant. Where are my solutions? Right there. That's my x1 here. There's my x2. And this is going to give me a different related acute angle. Related acute angle is blah, 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 blah. And I'll give you the... You should finish this. You shouldn't blah, 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 blah. But the solution set is overall, and again, I know I'm skipping some steps, but hopefully you get the picture. If not, make sure you ask about it in class. And finally, this mammoth, epic trig unit comes to a close. Probably we've already decided on a test day, at least one day of review after these, some for you to do in the textbook, a day of review or 2 days of review, and then we're on to something different besides trig. All right, that's it.